going to look at the classification of numbers. In order to do this, we have some concentric circles here, and each circle surrounds the other one, and that is important when looking at the classification of numbers. In the most center, now we could actually add another circle here that we're not going to talk about today, but natural numbers or counting numbers, as some people call it, can be in the very center. And what that is are numbers. If I were in kindergarten and I said, okay, boys and girls, let's count our numbers now, they would say 1, 2, 3, 4, and that's what counting numbers are. You start with 1 and you start counting all the way up to infinity. Those are also called natural numbers. The first circle in our classification numbers are going to be whole numbers. Whole numbers are all those natural numbers, which are also called counting numbers, and the number 0. So the only difference between whole numbers and natural numbers is the number 0. So with whole numbers, you would start counting 0 and then count up 1, 2, 3, 4, etc. Only, this does not include fractions, it does not include decimals, it does not include any negatives. Simply 0 and counting up. So this is the innermost circle called whole numbers. The next group is integers. Now notice that the circle for the integers also includes the whole numbers. So integers are going to be all of the whole numbers, and then we're going to include some more numbers, which are all their opposites. Whole numbers and all their opposites. What does that mean? Well, the opposite of 1 is negative 1. The opposite of 2 is negative 2. The opposite of 3 is negative 3. So integers, if you were to look at an integer number line, it would have in the center of it negative 3, negative 2, negative 1, 0, 1, 2. Still does not include fractions, still does not include decimals. It's all the whole numbers and their opposites, which means all the negative whole numbers. In the next circle, it's the largest circle, and it includes all whole numbers. It includes integers, but rational numbers also now includes all fractions, repeating, and terminating decimals. So if this were a number line, and this was 0, and this was 1, it now includes everything in between 0 and 1, as long as it is a terminating or repeating decimal and includes all fractions, such as 1/2, 25 hundredths, 67 hundredths, any fraction, 3/10, any decimal that comes to an end, which is called a terminating decimal, and all fractions. Now we will have to sometimes look at numbers. We'll look at one more group. This group is out here by itself. All of this, which was the whole numbers and the integers and the rational numbers, were over here by themselves. But this group that we're going to look at now is over here all by itself because none of these numbers are included in this group. Irrational numbers are going to be the numbers which are decimals that do not repeat or terminate. So these are the decimals that would go on and on forever, such as pi. You know that pi is a decimal that goes on forever. Also, when you take the square root of numbers that aren't perfect squares, they can be repeating decimals. So the square root of 5 and the square root of 3, it's not a perfect square. It is not a repeating or terminating decimal. It's a decimal that will go on and on. These are called irrational numbers, and they are a group all by themselves. So when we look here, we're going to just look at these three groups today: whole numbers, integers, and odd. And we're going to look at a number, and we're going to determine what group, even if there are more than one group, that this number belongs. Name all the sets of numbers to which each real number belongs. So 33, this is what I do. I think about my circles So this would have been the counting of rational numbers that we're going to do today. Here's the whole numbers, here's the integers, here's the rational numbers. If you can find what circle it's a part of, let's say it's a whole number. It's going to be a whole number and then work your way out. If it's a whole number, it's also an integer. It's also a rational number as an integer. Now, if it happens to be a negative, like a -3, that's an integer. So it would be an integer and a rational number. If it is a fraction or a repeating or terminating decimal, it's just a rational number. So if you can find what circle it belongs in, then you just work your way out to determine all the sets that it's a part of. So 33, I know that that is a whole number. I'm going to write my thing here. Here's our whole numbers. Here's our integers. Here's our rational numbers. So since 33 is a whole number, I work my way out. I also know that it is an integer and a rational number. This, if you look at this decimal, 585858, you can tell that the 58 is repeating. That means it's never going to terminate, or it's a rational number because it's a repeating decimal. -51 is an integer. Because it's an integer and you work your way out, it is also a rational number. -4/6 is a fraction. Fractions are part of the rational number group. -17, that is an integer, and then you work your way out, so it would be an integer and a rational number. 2 47/100 is a terminating decimal, so that is a rational number. So all whole numbers are going to be wholes, integers, and rationals, such as 33 was. All integers, like -51 and -17, are going to be both integers and rational numbers. And then all your fractions, repeating decimals, and terminating decimals are just going to be rational numbers. I hope this helps you with your classification of numbers.